Good afternoon. Welcome to Modules in One Lesson. My name is Mark Reinhold. I work on Java now and then. So this is mostly going to be an interactive talk. The title Modules in One Lesson might lead you to believe that I'm going to teach you everything you possibly could know about modules, everything there is know, but of course I can't. So a better title might actually be, modules the TLDR, modules skimming the surface, modules showing you a few cool things and basically how it works. So for reference, how many people were in Alex Buckley's talk, the session before the previous one? Excellent. So you've already got the terminology, you've already got some of the philosophy. What I'm going to do is show you some of how all this works in practice. So we'll explore a little bit. We'll see how modules are deeply wired into the system at both compile time and runtime. We'll look at the modular JDK fairly briefly, and then we'll actually take a little trivial Hello World app, convert it in a sort of gratuitous way, but it's good for illustrative purposes. We'll convert that into two modules and see how they interact and see how the strong encapsulation and reliable configuration that Alex spoke about actually shows up in practice and what it's like in reality. So with that, let me switch over here. Oh, and by the way, I probably will make a mistake or two. This is mostly going to be live coding, so if you think you can help, if you see me make a mistake, feel free to shout it out. Let's see, I'm here in my handy command line. I've got a Java runtime environment, and since I like living on the edge, this isn't 9. This is a 10 build that I made on this machine a couple of days ago, so it's a little bit past the most recent early access build that was posted last week. So hopefully it'll all work. I ran through it earlier and it did, but you never know. So this is a preview of 10, but of course it's largely compatible with 9, so that's not going to. Hopefully it just shouldn't be a problem. So first things first, and also a little side advertisement. How many people played with JShell? Isn't it great? Incredibly useful. So we're going to see some cool stuff here. Let me make a string variable. Just a quickie introduction to JShell for those of you who haven't seen it. I can type expressions. I can type int y equals 4 plus 3. And y is now 7. So I've got the string variable x, foobar baz, and I can since it's a string, well, I can invoke methods on it, right? What methods can I invoke? Well, hit tab, boom, and it tells you. We can find out how long it is. We can take a substring or a subsequence. Take your pick. We can do a matches operation on it. And that will be false because it's matches, not find. Anyway, you get the idea. So you can type little snippets of Java code in. They're evaluated right away. In a sort of implicit environment that logically includes a class, but that's all implicit, as Martin Odersky might say. The cool thing, so you can explore pretty much anything. So we've got this string object. What is its class? Well, it's a string. Duh, we knew that. Okay, new thing. As of Java 9, every class has a module. It's in a module. So we ask, what module is the string class in? It's in the Java base module. And if you saw Alex's talk, the Java base module is the one module that you always have around because it's got Java lang string and Java lang object and all those essentials of life inside it. So get module returned something, right? What actually did it return? Let's find out. It returned me an instance of a new class, java.lang.module, which is the runtime reflection of the module object as instantiated in the VM. So modules are deeply wired in. Not everything is in the base module, of course. We can do, for example, timestamp over in the SQL package. And $11 there is just a shorthand for the timestamp I just created. I can ask what is its class. Of course, we know what that is. It's a timestamp. We just made it. I can ask what module it's in, and I see that it's in the module called java.sql. And we'll come back and play with this a little more later on. Okay, so modules are deeply wired in. This is just runtime. The same is true as at compile time, as we'll see. Let's take a look at the JDK module graph itself. And I'll show you the whole thing. Alex mainly showed just the Java SE part of it. So there are some edges missing here. So Java base is at the bottom. You always get Java base, whether you want it or not. You can when you write a module, you can say that it requires java.base, but if you don't, the compiler will insert that for you. So imagine, if you like, if you want to imagine this graph as complete, there is an edge from every node that isn't java.base to java.base. But I didn't show that here because then it would be unreadable. And then the blue edges show the transitive reduction of everything else that's left, including the Java SQL module that we just saw up there. And you see Java SQL. This shows all the requires relationships, which modules depend upon others. What do you notice about this graph? Even if you mentally insert all the missing edges to java.base, it has an important property. What is it? No cycles, exactly. Cycles cycles spell doom in a modular system. So there are no cycles here. And in fact, the module system does not allow cycles. So let's take a look at the modules that we've got. New options to the Java launcher. It will list all the modules that it knows about, and there are a lot of them. In fact, there are 75 in an OpenJDK build. Let's explore those a little. Whoop. So we've got a whole bunch of modules that start with the letters JAVA. Those are part of the Java SE standard as of 9. And then there are modules that start with the letters JDK. Those are specific to the JDK and the implementation of Java SE. There are many things marked internal. There are some things that are not marked internal because they're actually APIs that you can use. They're just not part of the Java SE standard. So not only is the platform modular, but we also made the JavaDoc modular. Here's the JavaDoc for 9, the API specification, divided into 3 sections. And this is the front page. You're used to seeing this huge long list of packages. Well, now what you get is a shorter list of modules. Here are all the Java SE modules. You see Java base there. Scroll down, modules that are specific to the JDK, excluding ones that are strictly internal because you don't need to know about those. Java FX modules and other modules. And we go in here. If we go into Java base, then we'll see the actual list of packages inside it, including Java Lang. There's our familiar Java Lang package, and oh good, appendable, clonable, all of those essential things. Java Lang object. Yes, we still have Java Lang object. Let me go back up to the top here, and let's look at the SQL module that we saw a moment ago. So the SQL module, as we saw in the module graph, depends on some other modules, and if you hover over this little picture here, you'll get a bigger version of it. And this little graph is generated in the JDK build. It's all automatic, generates a dot file. It's then rendered into a ping that winds up in the JavaDoc that you can browse. So the platform is modular, the JavaDoc is modular. All right. Now, going back here. We did all this deep surgery on the platform to modularize the spaghetti code that the JDK had become over 20-odd years. We took great pains, as I mentioned this morning, to make it as compatible as we possibly could. As a demonstration of that, I have here swingset2.jar. Anybody remember swingset? Goes way back to JDK 1.2. 1998. It was the demo of the new Swing GUI toolkit. This is swingset 2 the jar file as found exactly in JDK 5. And I'm happy to report, actually, java-jar, I'm going to run it. And then remember, this is with my experimental 10 early access build. Same is true on 9, obviously. And it runs. Oh, hair swing set. Yay. All this stuff still works. This kid's, in grad school now. Whatever. So, yeah, the platform's modular, but it's also pretty darn compatible. All right, let's look at some code. So I've written a really trivial Hello World application, not the most trivial possible one, but a pretty trivial one. So we'll go into my favorite IDE here, namely Emacs. And here's Hello World in one screen. Public static void main, looks at the args, and then left pads the args so that the actual Hello World will show up on the right-hand side of the screen with this really sophisticated method here called left pad logically enough that just does the obvious iterative thing. All right, let's compile this and just show that, yep, you can do all this standard stuff. The class path still exists. We didn't take it away, contrary to rumor. Class path is still there in 9 and in 10. Let's see, Java C, classes. Tab completion is wonderful. I'll make myself a jar file. Whoop. Like I said, I would make mistakes. Let's see, Chili World, it's chilly in here. Hello, Chili World. Okay, isn't that sophisticated? I got a Ph.D. and I'm doing this, whatever. Okay, so we made a jar file, we ran it on the class path, all the obvious stuff. So first step is we'll take this trivial application, and since it's obviously needs to be reusable, right? We'll make it into a module. Well, that's actually pretty easy. So we pop up a couple levels of directory here. We're down in source org OpenJDK hello, because I'm using the reverse DNS convention. I'll pop up the module declarations go in the root. So they go in the source directory itself. They're always, by convention, in a file called moduleinfo.java. I say module, I'm going to call this module the same name as the package. And module names by convention should also follow the reverse DNS convention. Otherwise, chaos will ensue. Now, modules, if you heard Alex's talk, modules are, a module is a set of packages designed for reuse. This is a little application. Is it designed for reuse? Well, no, not in its life as a module. So in fact, it's not going to export anything. It's, yes, it's got a package, but there's no API here, so we don't have to say anything. I could say requires java.base if I wanted to, but that's tedious, and the compiler inserts this for me, so I just finish it off, and I'm done. So just to show you the logic of how to compile a module once you've got one. If you're just dealing with a single module, it's not hard. You can compile all of this stuff together. Of course, I understand most of you will be in an IDE and be using Maven, whatever. It'll just take care of all of this for you. One of the curses of working on the JDK itself is you're usually ahead of what all the tools support, so you just get used to doing things the hard way on the command line and with stone knives and bearskins. All right, so I've got a classes directory. Here's moduleinfo.class. I can run Java P on it, just like any other class file. A module declaration in modulinfo.java is compiled into a little class file. And Java P helpfully tells me what is in there now. So that's all good. I can jar it up, just like I did before. I'll just overwrite that. Whoop. I'll be lazy. Whoop. I'll be confused. So what we have here is it's a jar file, but it's now a modular jar file. It's got a module info.class in it. Otherwise, it's really just a plain old jar file. I can now run this on as a module by telling the Java launcher where the module path is. This isn't the class path, it's the module path. Modules are found on the module path. Module path lib -m org.openjdk hello. And this isn't going to work because that module doesn't have a main class attribute, so I have to tell it what the main class is. I get to type this one more time. And then that'll work. So one of the things you can add to a module descriptor after you compile it is a specification of the main class. Now, as a modular jar file, the cool thing about modular jar files is they work on the class path too. If you stick it on the class path, the module info.class is just ignored. So I can go back to my old, whoop. My previous example, I can take the same jar file, just stick it on the class path, and it works there too. So if you need to construct a library, say, that can be used on both the module path and the class path, you can do that. And if you take a little bit of care and, for example, compile all of the classes except module info for an earlier release of the platform, then that jar file can be used unchanged, even on JDK 8 or JDK 7 if you go that far. The module info class file will just be ignored. So this is a useful tool for migration. So to simplify life a little bit, I'm going to specify a main class when I make my jar file. Main. And now when I run it here, I don't need to specify the main class. Okay, so I've got the trivial application packaged up as a module. Not very interesting because, well, it is a set of packages. It's a set of one package. It's not really designed for use because it's an application. So let's engage in a powerful refactoring operation. We're going to take one module and split it into two. To do that, here's my source tree as it stands. I need to transform the source tree so that there's another level of directories. So there's a directory now, going to be a directory for each module that I'm playing with. So I'll move source over to org OpenJDK hello. Make myself a new source directory. And I'll move org OpenJDK hello in there. Now I'm all set up. The better structure, and I can now make another module next to it that's going to contain part of the original content. Okay, so let me get rid of that. And back to the main thing here. Okay, so what I want to do, and being inspired by JavaScript, is I'm going to make leftpad basically into its own module, because leftpad is obviously something that's difficult to write, and you should have a reusable version of it. So I'm going to make another module nearby called org openjdk.text, and let's go into org/open.text patter.java. Okay, so we're going to dump a bunch of code in here. Whoop. So we'll take this private method here and make it into an API. Okay, there's our pattern class, a nice static method. Let's change the code in main to use that. Don't need that anymore. We need to import org OpenJDK text. And here we need to run pattern.leftpad. Ooh. Okay, so that should be all good as far as the executable code goes. But now we need to fix up our module declarations, or actually we need to write one. So let's go back over here, write a module info for this new text module. So its name, we know that, is org OpenJDK text. Now, this module is a set of packages designed for reuse. So we need to export its one package, which has the powerfully sophisticated pattern API in it. And then correspondingly, over in the org OpenJDK text module, we need to change its module info. OpenJDK hello package module, rather. Yep, there we go. We now need to say requires. Sorry, I'm getting these all mixed up, aren't I? Okay. Text module on the bottom, hello module on the top. This guy needs to require org OpenJDK text. So this is the kind of fundamental pairing. If there's one lesson about modules to take away, it's that modules are related in two fashions. One is by requires, that's what gets you reliable configuration or reliable dependencies, and the other way is by exports. An export is what defines what is strongly encapsulated and what is not strongly encapsulated. If a package is exported, then its types are available to a module that requires the enclosing module. And we'll see some further examples of this later on. Okay, so I've got my module declarations. I've refactored the code. We've now got two modules in our little source tree here. Let's compile them up and see if we can make this thing run. So I'm going to use a little shortcut command here just to save some time. It's a little shell script that combines Java SE and jar, so we don't have to spend all day typing all of this stuff. So we'll compile the text module. Oh dear, you'd think I could type that by now. After all these years. Maybe if I had a proper IDE. Okay. I'm going to just remove that old one. So we've got our modular jar file for the text module. Let's compile the hello module. And this fails. It says module not found org OpenJDK text. Why is that? Well, because I need to tell the compiler where to find the modules that are going to be needed. So I need to use module path here as well. Oh, now what's going on? Oh my. Cannot find symbol. org.openjdk.text. Class text and package org OpenJDK. Very good. All right. So we've got two little modular jar files. Now I can run this application, Java module path lib, run the module org OpenJDK hello, and oh dear, I have that silly main class thing. Let me build this again. Ta-da. There we go. So at runtime, the module system, it finds org OpenJDK hello. It sees that org OpenJDK hello requires org OpenJDK text, so it loads that module up to it, connects them together. It interprets the exports to set up the access control, and all is good, and we get to write our little hello chilly world message. So, reliable configuration and strong encapsulation. How else do they show up in practice? Let's look at a few failure cases. Here's my lib directory. I'm just going to go remove the text module. And if I try to run this again, what's going to happen? Is it going to work? Well, no, of course it's not going to work. Modular org OpenJDK text not found, required by org OpenJDK hello. Will it work if I try to recompile the hello module? Well, no, it won't, because that's just not there. This is actually related to what we saw earlier. Module not found, org OpenJDK text. So another theme of the module system is fidelity at both compile time and runtime. As much as possible, the operation of the module system is identical in both phases. And that's with regard to both reliable configuration and strong encapsulation. And we've gone to some length to make the error messages as informative as we can, so that you can figure out what has gone wrong and fix it when that happens. Okay, let me remake the text module just so we have a complete working system again. All right, so here's another type of failure. What if I forgot this? I forgot to say requires. And I'll try to compile this again. Well, again, it does not exist. Is that what I expected to see? Yes. Right. So the module, right, is an example of a message so sophisticated I have to read it twice. So org OpenJDK text is not visible, is not accessible. And then the compiler explains, well, I see that you've got the org OpenJDK text package in the org OpenJDK text module that you put on the module path, but you didn't say that org OpenJDK hello requires it. Therefore, it wasn't set up to read it, which is the technical term that requires winds up enforcing. So let's put that back. All right, we compile that. Everything is good. Here's another thing that you might wonder about, or you might not. I said earlier that cyclic dependencies are, the module graph for the JDK itself has no cyclic dependencies, and in fact we forbid them because they are. They do lead to code that's difficult to understand and difficult to maintain. And the module system detects this. So here I'm putting in this other gratuitous required. So each one of these modules now requires the other. And I go to recompile the text module. Module not found org OpenJDK hello because, well, I didn't give it the module path. And now it will say error, cyclic dependence involving org OpenJDK hello. So yes, cyclic dependencies are bad news. The module system forbids it. That's actually not quite true. At runtime, if you really, really need to, you can use the reflection API to set up to set up cyclic read relationships. But it's basically something that's reserved as a workaround or for sophisticated libraries such as reflective frameworks to use. So we'll take that back out. And then a final thing about this is, well, what if I forget this exports? What if org OpenJDK text doesn't actually export that? Like I'll recompile it, and of course, this will recompile just fine. But now if I go to run the application, then I get this fairly verbose message, but it has a lot of information error in it. Illegal access error. Org OpenJDK hello main in module org OpenJDK hello cannot access the pattern class in the text module because the text module does not export the text package. And as I said earlier, we have fidelity at compile time and runtime. If I try to compile the hello module, then that also fails. It gives a similar error message to what we saw earlier. So this comes back to the point that Alex made. With strong encapsulation at the module level, public no longer means public. You can write public in front of a type, in front of a class, in front of an interface. You can have public methods inside it, but it will only be usable by code outside of the module that you're in if the module that you're in also exports the containing package. So this is a big shift in thinking. For 20-some years, public meant anybody can use it. That is no longer true. All right. There we are. Working again. Okay. So let's back up a bit. Looking at the module graph again. A really powerful thing that the modular platform enables is we can now construct custom runtime images that contain only subsets of it. If for example, I have a little application that is going to interact with a database, it'll require the SQL module that'll pull in logging in XML and Java base, of course, and nothing else is needed. Well, I can actually construct a custom runtime system that only contains those modules. Let me show you an example of how to do this for our little Hello World app. If I look, I've got this environment variable, $J points to the JDK build I'm using. There's a new directory in a JDK build as of JDK 9 called jmods. And that has a bunch of files in it. And if these names look familiar, well, that's good because these are the modules in the platform. They're in this new format called jmod, which is richer than plain jar files because we needed to be able to convey things for the JDK modules such as native libraries and legal notices and header files and all the other goop that you tend to find in a big application like the JDK. Anyway, so we've got all these jmod files, and there's a new tool called JLink. Java now has a linker, just like any other self-respecting software platform. You don't have to use it. It's optional, but you can use it. So we've got all these jmod files. I'm going to make a trivial Java runtime system that only contains the base module. So JLink, I need to tell it where to find the modules. I need to tell it where to put the resulting runtime system. We'll just call it JRE. I need to tell it what to include. Well, we need the base module. And it goes off for a while and it thinks. And then I've got JRE. It's got a bin directory with the Java launcher and key tool in it because, well, key tool. I can look at how large these things are. The full JDK is 491 megabytes, and this little teeny JRE I built is only 44. So that's cool. I can ask what modules are in it, and, well, it only has the base module, which is what we expected. But the base module is all that our trivial little app needs, so I can run it. Which Compatibility. And there's some useful diagnostics. For example, show module resolution. This will show the activity of the module system's resolution algorithm as it figures out, okay, we're starting with the root is org OpenJDK hello. It sees that org OpenJDK hello requires org OpenJDK text. It gives you the URI of where it found the corresponding jar file, and then it ran it. You know, for a more sophisticated application, you'll get many lines of output if you use this option. So I can not only make a custom JRE for an application, but if my application is modular, I can J-link those modules into the custom runtime system as well. Let me show you how that works. So I'm going to run J-link again. I need to tell it where to find the JMods for the platform itself, for the JDK, and also my two little modules. I'll output this into HJRE, say. I need to tell it what the root module is, where to start, so I say add modules org OpenJDK hello. And since it's going to make a custom runtime system for me, I can ask it to make me a little handy command in the bin directory that will launch my application. And just for amusement, I will make it even smaller by using a couple of other options. J-link has quite a few options in it for customizing its output. I'm going to strip debug info, and I'm going to compress the class files in the module archive. And this will go off and do some work. Takes a little longer because it's doing a bunch of compression. And here's my hello world JRE. Since it's compressed and doesn't have debug info, it's even smaller than the plain one that just had java.base. And there's my hello command. There we go. All wrapped up in a nice little JRE optimized into one little package. You can throw this into a Docker file, deploy it somewhere. You know, imagine it's a more sophisticated application, of course. And you're only going to, your Docker file won't contain Corba. It won't contain JAX Web Services because, well, you don't need them, and it'll be nice and small. All right. That is all that I've got prepared for right now. There's a ton of information about Project Jigsaw on our project page on OpenJDK. Most of the essential information is in the JEPs, the JDK enhancement proposals numbered 200, 201, 220, 260, 261, and 282 covers the linkers. So all of these contain lots of useful information. 261 is probably the most important one. It explains all of the command line options and how the module path works, and in much more detail than I've been able to show here. JEP 200 is an overview of the modular JDK itself. 220 discusses the way that the runtime image structure has changed. RT.jar has gone away. We've provided better alternatives. JEP 260 is about the encapsulation, or in many cases non-encapsulation for the moment, of internal APIs. Of course, you can get JDK 9 now at this URL. Don't believe a word I've said. And we have 11 minutes left for questions. Questions? Applause. Oh, thank you. Do we have microphones up? There are microphones there and there. So if you'd use those, that would be great. Otherwise, you have to trust me to repeat your question, and I might get it wrong. Yes, sir.
I noticed a small discrepancy between the talk of Venkat and yours.
Oh, no, well, Venkat was wrong.
Okay.
Oh, no, wait, Venkat's never wrong.
When he did the module search...
Do we have a hand mic we could give him?
So when Venkat did his talk on Java 9, he also did the module search, and he came up with 95 modules.
He did. You're right. I can do that too.
Yeah, but where's the difference?
Where's the difference? So the difference, it all rests in what you're running. So this is an OpenJDK build that I built on this machine. And as we saw, it's got 75. So what Venkat was using, I'll hazard a guess, was an Oracle JDK build. And remember, if you were at the keynote this morning, there's this difference between an OpenJDK build and an Oracle JDK build, because Oracle JDK has a bunch of commercial features in it and some other stuff, and so it's bigger. And so funny you should mention, I actually happen to have an Oracle JDK build here. Here's the latest 10 published early access Oracle JDK build. Oh, it's 97. He said 95?
Yeah, I noted it down.
Don't know where you got that number. Oh, maybe. Well, maybe.
Yes, he was running 9.
I'm going to get to the bottom of this. I don't know. Okay, here my guess is Venkat was running a stale JDK 9 Oracle JDK early access from early summer or late spring or something like that. Okay, quick, somebody tweet it at him and find out. Good question, though. Sharp eyes. Anybody else? Ah, how convenient.
Is class loading any faster?
No, closer.
Is class loading any faster?
Is class loading any faster? Yes, class loading is faster. Why is class loading faster? Because we're not doing that stupid linear search of the class path.
I have another question.
Okay.
Sometimes we generate bytecode on the fly, right?
Yes.
In a modular system, where does it go? I mean, which module does it belong to?
So if you generate bytecode on the fly, where does it wind up? It usually winds up in the very module that you're already in. But if you need it to be in some other module, you can arrange for that too. So yeah, bytecode on the fly, all of that stuff still works. Any other questions? If you don't ask a question will be provided for you. I haven't heard the most popular one yet. This is spooky. The camera just follows you.
Sorry. Do you support versioning of modules?
Thank you. The winner is, we have a winner. Do we support versioning of modules? No, we don't. And why do we not do that? Because, well, the short snappy answer is because Maven and Ivy and Gradle already do that, so we don't do it. There are a bunch of more sophisticated answers. I mean, a sort of more sophisticated language designery answer is, well, modules are a different thing than the artifacts that define them, right? We make a clear distinction between a class as the sort of platonic thing in your program versus the Java source file that defines it pre-compile time and the Java class file that defines it after compile time. Right, they're different things. So a module is like a class. It has some higher plane of existence. It's defined by a jar file or a JMod file. Versions belong on artifacts. Versions don't belong on modules. We don't version classes. We don't version packages. We version jar files. And so continuing to version jar files from a sort of philosophical standpoint is what makes the most sense. From a purely pragmatic standpoint, we actually did in a very, very early Jigsaw prototype, we actually did have versions and version constraints. And we realized fairly quickly, we're solving the same problem that Maven, Ivy, and Gradle already solve. They all solve that problem in somewhat different ways. So no matter what we do, it's not going to work well with at least two of them. And everybody uses those tools. And we knew better than to think that we could make everybody use some other tool, even if it was in some theoretical sense better. So we just backed off and said, okay, no. The best approach is to leave version selection to the build tools and the configuration of the build tools, and work with the maintainers of the build tools to make sure they work well with the module system. And I've been pretty pleased with the help we've gotten from folks like Robert Schulte, who works on Maven. But don't try to compete with them. So that's the sort of practical answer for why we don't do versions. Will we ever do versions someday? No, probably not. This is a kind of counterintuitive thing at first. It was like, oh, well, it's a big hairy problem we don't need to solve. Cool, that's the best kind. Any questions elsewhere? Obviously, I'm biased towards the lower rows here.
Still related to the versioning question. If we have, let's say, a Maven project and we need a certain dependency, would we specify the version in the POM file, and we would also specify the module name in our requires section of our module?
Yes.
And it would be Maven's job to bring that jar?
It's Maven's job to bring the jar, and it's your IDE's job to make sure that the information in your POM and the information in your module info are consistent, as indeed both Eclipse and IntelliJ are doing or will soon do.
Okay, thank you.
Mm-hmm. Yeah, and I realize it does seem a bit redundant. It's like, oh, module info, POM XML, aren't they the same? Couldn't we just have one thing? And the answer is that would actually be more confusing than it's worth. 3 minutes. Any other questions? Questions up at the top? There are 2 mics. There's a question down here.
Hello. Yesterday we've found out that in a previous version to the latest one, there were no numbers in the module names. Why was that, and why was it removed after all?
So numbers are allowed in module names, but they're almost always a bad idea. So they're allowed in module names because numbers have been used in the names of a few popular projects. A lot of the design of the module system was informed by scans of Maven Central to figure out what kinds of names did people use, what was popular, what wasn't, what caused trouble. But you find things like SLF4J. Okay. One of the anti-patterns we really want to discourage is thinking that modules should have versions and then putting the version numbers in the module name. This would be an extremely bad practice. So we thought for a while, and this was in the Jigsaw design for a while, okay, let's disallow module names that had digits. And that's kind of an ornery rule to have. And eventually, as people were looking at it, and it was becoming more and more widely known, people were like, yeah, that's kind of too mean. We get your point, but it's too mean. So we took that rule out. That's why it's no longer there. But please do not put version numbers in your module names. It will lead to tears. 1 minute left. One last question. Anybody? Oh, sorry.
Is linking a custom GRE now the preferred way? And what about security patches when I create a custom GRE which is bundled to the application?
To answer the first question, well, is making a custom GRE preferred? Well, no, it's another option that you have. You don't need to do it. You can run Java from the command line like you always have. You can toss WAR files into your app server that's running on top of 9, like you always have, and it'll work. Second question was what about security fixes? Well, if you're packaging a JRE with your app, and there are people who've been doing this for years, then you are taking on the responsibility to provide updates yourself when security fixes are made available for the JRE that you're using. So that's one of the costs. and you can choose to take it or not. All right, time's up. Thank you very much.